Okay, let's dive right in. We hear these terms, AI, machine learning, deep learning, thrown around all the time, right? And a lot of the time, they're used like they mean the same thing, but they don't. So in this explainer, we're going to cut through all that noise and show you exactly what each one is, and more importantly, how they all fit together.
So if you've ever felt a little fuzzy on the exact differences, hey, you are definitely not alone. These are way more than just buzzwords. They represent different layers of a really fascinating field. And getting that difference is super important.
You know, the simplest way to get your head around the relationship is with an analogy, Russian dolls. It's honestly a perfect mental model. You've got that big doll, and inside it, there's a slightly smaller one, and inside that, an even smaller one. Each one is its own thing, but they all belong to the same family. So let's start unpacking them.
So here it is, laid out plain and simple. Artificial intelligence, or AI, is the biggest, outermost doll. It's the whole concept. Nested inside of that is machine learning, or ML, which is a subset of AI. And then finally, tucked inside that, we find deep learning, or DL, which is a specialized subset of machine learning. So just remember, all deep learning is machine learning, and all machine learning is AI. But, and this is key, not all AI is machine learning.
So let's start with that big outer doll, artificial intelligence. This is the broadest concept of them all, the big picture. It's the entire field dedicated to one massive goal, building machines that can do things that would normally require human intelligence. Let's look at the official definition. The key word here, the one to really hang on to, is tasks. AI is all about creating systems that can perform tasks that need a human brain. You know, things like reasoning, solving problems, seeing the world, and understanding language. That's the ultimate goal. Think back to early AI, like IBM's chess-playing computer Deep Blue. That thing was a masterpiece of human programming. It was what we call a rule-based system, which means programmers had to painstakingly code every single possible move and strategy by hand. It was intelligent, for sure, but it was also kind of brittle. It couldn't handle anything outside its pre-programmed rules, and it couldn't learn a new strategy on its own. That limitation is exactly what pushed us to find a better way. So let's open up the next doll inside and see how this all builds. We've just entered the world of machine learning. Now, this is where things get really cool. Instead of a programmer sitting down and writing rules for every possible thing that could happen, the machine learns the rules itself just by looking at data. This was a revolutionary leap forward that got us past the brittleness of that old-school AI. The crucial shift here, the real game changer, is going from programming to training. Think about your Spotify recommendations. That's a classic example. An algorithm is trained on data. Your listening history, what you skip, what you put on repeat. It learns your patterns to predict what you'll want to hear next. Other types of machine learning can even find hidden patterns in data all by themselves. It's this ability to learn from experience that really defines modern AI. Okay, before we open that final tiny doll, let's put machine learning and deep learning head-to-head for a second. You can kind of think of it as a trade-off. On one hand, standard machine learning is way more accessible. It works with smaller data sets, it can run on a regular computer, but it often needs more hand-holding from a human. Deep learning, on the other hand, is a whole different beast. It demands massive amounts of data and specialized computer hardware, but in return, it can learn more on its own and often achieves a completely different level of accuracy.
And this brings us to the very center, our innermost doll, deep learning. This is a super powerful, specialized type of machine learning. And its core inspiration, well, it's one of the most complex things in the entire known universe, the human brain.
So, our brains, right? They're made of billions of these interconnected cells called neurons. Each one gets signals through its dendrites, does a little bit of processing, and then sends an output signal down its axon. This simple biological setup is the direct model for how deep learning works. And this slide just illustrates that connection perfectly. On the left, you see the biological neuron we were just talking about, and on the right, you've got a diagram of an artificial neuron. You can see the parallels immediately. Inputs coming in, a little processing node in the middle, and an output going out. That design is absolutely intentional. Let's make that mapping super explicit. The dendrites, which receive the signals in a real neuron, are just the inputs in the artificial model. The cell nucleus, the brain of the cell, is the node where the processing happens. The synapse, which controls how strong the connection is represented by weights. And the axon, which carries the signal away, well, that's your output. So how does one of these artificial neurons actually, well, think? It's a surprisingly simple three-step process. Let's walk through it. First, it multiplies each input by a weight.
That's just a number that represents how important that specific input is. Second, it adds all of those weighted inputs together to get one single value. And finally, that sum gets passed to an activation function. This is like the bouncer at a club. It decides if the combined signal is strong enough to matter, and if it is, it fires, passing the result on as an output.
This diagram gives us a perfect picture of that flow. You can see the inputs on the left, each one getting adjusted by its weight. They all get added up there in the middle. That result then goes through the transfer, or activation function, to create the final output. And a deep learning network, it's just thousands or even millions of these simple little units, all layered together to learn incredibly complex patterns. So you might be asking, why go through all this trouble to mimic the brain? What's the big payoff? The payoff is the ability to recognize incredibly complex patterns in data. Patterns that would be impossible for a human to program or even for simpler machine learning models to find.
And that ability is absolutely transforming our world. Deep learning is at the heart of systems that can spot cancerous tumors in medical scans, sometimes with superhuman accuracy. It's what lets a self-driving car tell the difference between a pedestrian and a lamppost. It's used to generate art and music, translate languages in real time, and do crazy sophisticated object detection for security. The list just goes on, and it's growing every single day. So let's bring it all back to our Russian dolls one last time, just to lock it in. Deep learning, that powerful, brain-inspired inner doll, is a specific type of machine learning. And machine learning, the middle doll that learns from data, is one of the most powerful ways we have today to achieve the overall goal of artificial intelligence, our big outer doll.
And that brings us to a final, kind of mind-bending thought. These deep learning systems are getting smarter every day, constantly being fed by these ever-growing mountains of data from around the world. They've already mastered games, image recognition, and language. So the real question is, what quintessentially human-like task is next on the horizon for them to master? Something to think about.